Hi everyone, this is Jitendra Chaubisa from Civil for Sure Academy, and we are going to talk about shear wall in this particular video. Now, we are going to see the basic concepts related to the shear wall, that is what are shear wall, how they behave in our structure, why we actually use them, what are the design consideration that we need to do, and we are also going to do a demonstration on our one of the software, that is Staad Pro, and we are going to model and analyze and then design it. We are also going to produce the design sheets of the shear wall. So let's start one by one. Okay, now what actually are the shear walls that we need to understand? Now, what is a shear wall? It's a vertical structural element used in a building to resist the lateral forces. It is not going to be like a common wall of a brick or a masonry. It is going to be of very rigid material, that is of reinforced cement concrete, and it is going to be useful against the winds and the earthquake. It acts like a strong wall that prevents the building from swaying and collapsing sideways. Okay, now why actually they are called as, you can say, the shear walls? It is called a shear wall because it resists the shear forces, and these are the forces that try to slide one part of the structure past the another during an earthquake. We know that at the time of, you can say, the earthquake, the columns and the beams get, you can say, the differential bending moment and the shear force, and as a result of that particular thing, the shear forces arises. So these strong, you can say, the parts of the buildings are going to act like an shear wall resistors. Okay, and they are going to what? Pose the, you can say, the shear resistance. Now let's talk about the purpose and the function. The first purpose is going to resist the lateral forces. I already told you, in the high rise building or the tall buildings, from the side to side forces caused by the wind and the earthquakes, the shear walls are going to be very helpful. The second is going to be it provides the structural stability, and it is going to make our structure very rigid. It is going to help the buildings from tilting, swaying and collapsing during the lateral loads. The third case is about the improvisation in the building's rigidity. The overall rigidity of building is going to increase, and it is going to reduce the vibration and the displacements. Now, so overall, it is going to enhance the earthquake resistance, the critical component in the seismic design to minimize the damage during the earthquake, that we are going to do with the help of shear walls. Now, the use case scenario where we are going to use it, first we are going to use in high rise buildings. Okay, it is essential for the resisting the, you can say, lateral forces in tall structures. Similarly, the high seismic zone where the area is very prone to earthquake, we are going to use the shear wall in our structure. The areas where cyclone or wind prones are there, which areas are very, you can say, prone to the cyclone and all those things, we are going to use the shear walls. And the fourth last thing is, that is in the industrial structure also, because there are going to be very lot of, you can say, vibrations are going to be there, very lateral forces will be there with the because of the equipments, we are going to use the shear walls there. Now, the basic behavior of shear wall, the first thing is it acts like an cantilever. Okay, it is fixed at the base and you can say it is free at the top, so it is going to act like an cantilever. Now, the second behavior is it is going to improve the lateral stability by transferring the lateral loads to the foundation. It is going to be a rigid member which is fixed at the base and you can say free at the end. So whatever the load is going to transfer from the right hand side direction or the lateral direction, it is going to transfer all those load to the foundation. And the third basic behavior is it is going to make our frame very rigid. It is going to work in combination with beams and slab and columns. It is also going to be constructed monolithically, or you can say the concrete is going to be casted monolithically with the beam, slab and column, going to make them as a one rigid framework, which in result going to increase our lateral stiffness. Now, how generally constructions are done, what are the major parts that we need to consider at the construction of shear wall? First is the placement, where we are going to place the shear wall. Generally, they are going to be placed at the, you can say, the corners or around the staircase or around the lifts. They are also at the cores for the high-rise buildings, and if the area is prone to very high earthquakes, it is going to be also placed at the ends of the building. Now, the formwork needed for the construction will be jump formwork or slip formwork. This kind of a formwork moves from one floor to another floor after, you can say, the casting. It is generally done with the help of hydraulic jacks. The reinforcement is going to be kind of similar to the slabs. It is going to have a vertical rebars, that is the main tension bars, and the horizontal distribution rebars are going to be there for the, you can say, serviceability criteria. The concrete is pouring is going to be monolithically, as I have told you earlier, with the slabs and the columns. And what are the material used? What are the kind of, you can say, shear walls? So generally, the most common one is the reinforced concrete one, because it is going to give us, where you can say, the high rigidity, and it is the materials is easily available. The second one is the precast concrete, which is kind of very useful in 3D printing type of cases, or you can say the PEB case, pre-engineering building types, we can use the precast concrete, which is going to be very speedy and quality. Steel plate shear walls are also there, which is less common, but they are going to give us the higher strength. Masonry is there, but it is going to be used in low-rise areas where the seismic zone is kind of a very low. According to Indian Standard Code, if the seismic zone is zone 2nd and it is only G+2 or G+3, you can go with the masonry also. Okay, there are wooden shear walls also, but they are not that much, you can say, common in India and the nearby countries. Now let's talk about the shapes. What are the basic shapes of the shear wall? You can see there are photos in front of you of a shear wall from a research paper. This can be simple rectangular or a square. You can see at the center we have a square rectangular wall. It is colored in red. Okay, the screenshots are from E-tabs actually. It can be of L-shaped. You can see at the corners it is kind of an L shape, and this photo also you can say it is of L shape. Okay, it can be used in the core wall system at the center. It can be used to increase the lateral stiffness. It can be of T-shaped, C-shaped, and it can also be of U-shaped. Okay. Now, what are the major design considerations? There are major 5 design considerations that you need to finalize before you can say modeling the shear walls. First is the load path. You must have to choose the position very, you can say, perfectly, that the load is going to be transferred to the foundation very efficiently. Okay, that is the main, you can say, concept here. Then we need to consider the aspect ratios also, that which will affect the load distribution and the wall behavior. If there are any openings in the shear wall, you need to take care of that particular thing also, because in the case of openings, there are going to be stress concentration at the edges that we need to be taken care of. Symmetry must have to be there. If there are major several shear walls in our model, then we must have to make a symmetry. Like it must not have to be the case that all of the shear walls are at, you can say, the right side of the model. Then what that will do, that will increase the CG on that particular side, or it is going to shift the CG of the structure on the right hand side, and then the center of rigidity will change and the torsion will appear and all of the headaches will come on to us. So the symmetry must have to be there. The equal distribution of shear walls must have to be there in our model. Slenderness must have to be checked to, you can say, prevent the buckling under the loads. Okay, so these are the mainly 1, 2, 3, 4, 5 parameters that we need to consider, you can say, in the shear wall. So this was all the basic idea about the shear walls. So now what we are going to do in the second half of the video, we are going to do a demonstration on the software. We are going to use the Staad Pro. You can also go for the Staad E-tabs. We are going to model and analyze our shear wall and the structure in this particular software. Then we are going to move in the Bentley RCDC, that is Advanced Concrete Design, and we are going to do the designing and detailing of the structure there, and we are going to get the design sheets of our shear walls. Okay, so let's go. Now see, I have modeled a simple structure here. It is 1, 2, 3, 4 story building is there. If I'm going to go to utilities, node tools, and node to node distance, we can see the distance from here to here. That is, it is of 3 meter high, and this is 24 meter long and 24 meter wide. One span is of 6 meter, and all of the things are like that. Now the another thing is that the properties I have already assigned to all the columns. The columns are of 500 mm by 500 mm, and all of the beams are of 250 mm wide and 500 mm depth. The material is concrete. It is all of RCC. Now suppose we need to make a shear wall in this particular structure. Like I'm going to click shift right click, and I'm going to hit shift on the keyboard and click right click with that particular thing. This pop-up is going to get appear. I'm going to go onto the top view. Suppose I want the shear wall to be made here in a boxy, you can say, way. Okay, I want a box shear wall here. So how we can do? First of all, we need to delete all of these beams. We also need to delete the columns, but we are going to delete column afterwards because they will help us to create the, you can say, the shear walls. So how you can delete the beams? By pressing Ctrl on the keyboard, select all of the beams. All of the beams on the downward floors are going to get selected automatically. I'm going to press delete and I'm going to press OK. So this is going to delete all the beams. Shift right click and see the perspective view. Right click, go onto 3D rendering, and into 3D rendering by simple left mouse, you can say, movement, you can see here that the shear wall has gone, but there are still columns here, but columns will stay there. We will delete them afterwards. Now I am to make shear wall in between them, but it is kind of very, you can say, typical, or you can say it is very right now mushkil hai bahut, you can say it is very tough to draw the shear wall at this particular time, because the view is very clumsy. There are many columns and shear walls in the view. So what we are going to do, we are going to first make the shear wall at only a single floor, and then we are going to replicate it. But how we can draw at a single floor? So for that, what you can do, press shift right click and see the front view, select all of the members from the first story, or you can say the bottom story, then right click, click new view. So we are going to display the view in the active window. I am going to press OK. Now again shift right click, go to the perspective view. Now the only one floor is here in our front view, in our you can say view. So we can now easily construct the shear wall. For the shear wall, you can go into the geometry. In the plate, we are having parametric models. In the preview models, click on add. Okay, you can click on add, and then you can click the corners like first, second, third, fourth, and click on the point where you have started at the last. Okay, so I'm going to click on that particular point where I have started. Then there is going to be pop-up window. That is what name you want to give it. I want to give it the default name. In the type, this is a wall. I'm going to select wall. In the subtype, press undefined. In meshing, you can use either of two. I'm going to use the quad. For the boundary connection, I'm going to use the optimize. You can also define any, you can say, segments you want at the boundary for the stress concentration. For the target element size, this is the size of the mesh. I am going to use 0.5 meter. You can use the higher mesh size also, and you can go for the lower size also. If you want to learn more about meshing, you can see our video on the meshing. We have very elaborately explained that what a meshing is. Always check this box, that is create density objects from the internal loads and the beams. I don't have any opening, so I'm going to uncheck it. I'm going to press OK, so one wall is there. Click again on preview model, click on add, and add the another wall. I'm going to do them one by one. Okay. Again, the pop-up window is going to be there. Okay, select all these things as per your requirement. I'm going to do the element size of 0.5. Again, click on preview model, click add, and add the third one like this. The same thing you have to do. I'll press OK. Again, I'm going to click on preview model, add, and click to add, click, click. 0.5. I'm going to use the 0.5 of meshing size. All of you can say the surfaces has been made here. Now what we have to do, we have to mesh them. Okay, so you can mesh, you click on first of the wall, click on merge mesh, then move on to the second one, click merge mesh, onto the third one, click merge mesh, and onto the fourth, click merge mesh. Now the walls has been made. Okay, you can just right click, you can go on to any different, you can say section, click on 3D render, and you can see the shear wall has been made up. But we need to provide a thickness to this shear wall. So go on to the property, select thickness, okay, and in the thickness, give it a thickness of 200 mm. Okay, that is 0.200 mm. Click on add, and you can go on to select. Under the plate, select all the plates, because all of this shear walls, meshes, or you can say plates, will be considered under this category. So select the property, select the mesh, assign to selected plate is selected, click assign, yes. So it will be assigned to it. Now if I'm going to right click 3D render, I can see here, go into view, click zoom, and make a box here. You can see now there is a thickness to this wall. You can also make the thickness to 250 mm so that it will match the width of the beam and the construction will be easier at this site. Now what we need to do, we need to copy paste it to the upper floor. So shift right click, click on display whole structure. So the whole structure will be displayed. Now you can go on to select in the plates, that is all plates will be selected. I am going to replicate it with the help of geometry and this option, that is translation repeat. I want to translate this in the y direction. Okay, this is the y direction. You can say the vertical direction, and for how much times I need to copy paste this? I need to copy paste 1, 2, 3, 4 times. And what is the height? The height will be equal to the story height, that is 3 meter. And 1, 2, 3, 4. That is, I'm going to write 4 in the steps, and default spacing will be 3 meter. I'm going to press OK. So one by one, it is going to copy paste it onto the, you can say, top of the structure. So all of the, you can say, shear wall has been made. I can click right click and go into 3D render, and I can see the shear wall has been made. Go to view, click on zoom, and make a box here to check the structure carefully. Now there are columns at the 4 corners. We need to delete these columns. Actually what happens, whenever the software is going to design the shear wall, it is going to by default consider the 4 columns at the corner. That is known as CNT design, that is compression and tension reinforcement design. So we need to delete these columns, or else what will happen, you can say it will become very over reinforced. So for that, what we can do, shift right click, go on to top view, and try to zoom at this particular position. Okay, and then go on to select beam cursor, and with the help of beam cursor, just select the particular, you can say, just cover that particular portion. You can go into geometry also. Just select that particular, you can say, a corner and press delete. It is going to delete all of, you can say, the columns from there. Okay. Similarly, I'm going to select this corner. I'm going to delete. Okay. Then I'm going to click delete. Delete. It is saying 30 beams are deleted. Why 30 beams? The story is only 5 story, so there must have to be 5 columns only. But remember, we have done mashing. So what it does, the software does, it meshes the columns also. So it divides those columns also. So in that particular way, it becomes so much of like 30 beams. I'm going to delete all of these beams also. Similarly, click cover this one, click delete, and it is going to delete. Now shift right click, go into display whole structure, right click, go into 3D rendering, and check the columns are gone or not. Yes, we can see it from here that the columns are almost gone. So the thing is that our shear wall is remaining. Now all of the things have been done. Property has been done. Material is concrete. You can go into concrete, and if you want to give any grade, you can give any grade, or like that you can keep it as it is. I'm going to change the grade in the design commands. You can go into the supports. Now what in the supports, everything must have to be fixed at the bottom. So right click shift, see the front option. Okay. From the front, I'm going to create a fixed support here, and by selecting, you can say support, I'm going to cover like this. I'm going to make a box like this. This box needs to include the only, you can say, the bottom nodes of the shear wall like this. So all of the bottom nodes of the shear wall has been selected, and all the bottoms of the respective columns has been selected. So I'm going to assign fixed supports to them. So the fixed supports is going to be assigned. Shift right click, go into, you can say, the parametric view. You can see all of the fixed supports are there at the bottom of, you can say, what, our shear wall, and all the columns are now also having the fixed supports. I'm going to save this structure. Now you can go into loading, and in load cases, give it any load cases. I'm going to give it a dead load case. I'm going to add it, and also I'm going to give it a live load. Okay, live load is going to be there. Now in the dead load, take the self weight of the whole structure. I'm going to add, and I'm going to take the self weight of the structure. I'm also going to have a member load of uniform force. Suppose there is an brick masonry on all the beams, and it is applying a 10 kilonewton meter of load in y direction. So I'm writing minus to show the downward force. I'm going to add it onto the backward. I'm also going to take a floor load here. Floor load will be minus 2 kilonewton per meter square. You can consider it as in floor finishes. And we need to consider the Y ranges here. That is, it is acting from, suppose I'm going to do the utilities node to node distance. I want this from this particular portion to this particular, that is from 3 meter to the 15 meter. Okay, so I'm going to write minimum 3 and maximum 15. Okay, that is top of the structure. In X range, as I have told you earlier, we were having like 24 meter wide of the, you can say, structure. So minimum is going to be 0 and the maximum is going to be 24, and same in the Z also. Okay, and we are going to provide in global Y -2. So I'm going to add it. I'm going to close it. If I'm going to click on floor load, you can easily see from this floor all of the loads has been assigned. Click self weight, assign it to total view. I'm going to assign it to the whole view, and then if you want this -10 kilonewton meter is only on the beams. So to select the beams, there are, you can say, 2 methods. First method is go into the select option. In the beams, go into parallel option. All of the beams are either parallel to X or parallel to Z. So either way you can select it. But the most convenient method, or you can say the most economic method, is that you can make a group of it. Okay, how you can make the group of it? Go into utilities, go into groups. Okay, and make a group of beam. To name it as beam, in the select type, select beam, and press OK. Now whatever this objects are selected at the background, suppose they are beam and they are in actual beams, I'm going to click on associate. This option is going to work only after selecting the members. Okay, so I'm selecting all of these members and I'm telling them they are associated to the group of beams. So I'm going to click associate. So all of these beams are associated in the name of beam group. Similarly, what I'm going to do, I'm going to select, and in beams parallel to Y, that is all of the columns will be selected because they are parallel to Y. And in that particular case, again, I'm going to be in utilities, and in the groups, I can create a new group, name as column, and this select type beam, it is also a type of a beam. I'm going to press OK and I'm click associate. So all of this member will be associated to the column group. So like this, I can select all of these things in one go. Now, if I want to apply this -10 kilonewton of meter onto the all of the beams, so I'm not going to again go to the select and parallel Y and parallel X. So I'm going to select the group. So by selecting group, click on highlight. All of the beams will be selected. The load is selected. I click on assign to selected beam, assign, and yes. So this is an, you can say, optimum way of doing it. Again, in the live load, I will go there and click on add, and I'm going to again add a floor load here. We are going to provide a minus 3 kilonewton per meter square of live load in global y direction from the same 3 to 15 and 0 to 24 and 0 to 24. Okay, and I'm going to press add, and I'm going to close, and I'm also going to close all of these things. So you can say the live load is also there. Let's generate one of the combos also. I'm going to add combinations here, that is auto load combination according to the Indian standard code. I'm going to do, I'm going to generate load, I'm going to add and close. You can do all of the seismic loadings and the wind loads will be there, you can do. Okay, for the simplicity of the tutorial, I'm skipping the, you can say, the major things. Go into analysis, define a command of just an analysis, click on add, close, go into design, press concrete because we are designing concrete. I'm going to select the Indian standard IS 456 code, and I'm going to define the parameters here. Okay, you can click the, you can say, the parameters here, like I'm going to consider a compressive strength as M30, that is 30 Newton per mm square. Okay, so I click on define parameters, go into FC, and here you can write like 30. I'm going to write 1000 because it is asking in kilonewton per meter square. I'm going to press add. Similarly, Fy main is the yield strength of the main reinforcement. I am going to use Fe 550 rebars, that is 550 Newton per mm square of yield strength. So I am going to write 550 000, sorry, 550 1 2 3 in kilonewton per meter square. Similarly, secondary reinforcement needs to be checked. So 550,000. Okay, add. You can also add the other things also, like minimum reinforcement, maximum reinforcement, all. I'll go in the commands and I'm going to design beams. I'm going to add the design beam command, design column command, and design slab element command for the walls. Okay, now we need to assign all of the things. These top three things, that is the grade of concrete and the steel, is going to be assigned to the whole view because every member needs you can say this property. So I'm going to assign all of these things to the view. Okay, similarly the secondary view and all of these things, assign to view, assign. Then I'll go to design beam. Now I want to assign this particular, you can say, command to only the beams. Okay, so I want to select the beams again. So again, that group is going to help us. Go into the utility, there is group, or you can access the group from by pressing the space bar. By pressing the space bar, this quick commands is going to be there. You are not going to have the group option here at the initial point, but you can add them by clicking at this particular point. Okay, and now onto the left hand side you can search for groups, and then by selecting group, press this button, the group will come onto the right hand side. So there will be quick command by pressing, you can say, space bar. So I have a group here. So in the group I will select, you can say, the beams, and I'll click on highlight. All of the beams are selected. The design beam command has been selected. I'll select assign to selected beam, assign yes. So that command will be applied to only the beams. Similarly, I'll select design column, then I'll go to column, highlight all the columns, and then I'm going to select the assign to selected beams, assign, and yes. Okay, so this is done. Similarly, you can do it for the plates also, but I'm going to this time select the plates by manually going to the select, and in the plates I'm going to select all the plates and I'm going to assign them. Okay, yes. Now everything has been done. We'll go into the design and we'll click on run and we'll start the designing. Okay, so now what we are going to do, we are going to just design it. We are going to hit run and it is going to design as per our method, and it is going to design beams, columns, and the slabs also. Okay, so we are mainly concerned with the shear wall in this particular video, so we are going to focus on that particular thing. Okay, so the designing has been going on and the designing has been done. There are two ways to check the reinforcements. First one is from the view output file. I'm going to click view output file and I'm going to press done. It is going to open up the output file. Okay, we'll wait until it opens up correctly. Let's maximize it. Onto the left hand side we have concrete design with starting from beam. We are having designs for the beams and all. I'm going to zoom it with control and wheel up button. You can see these are the top and bottom reinforcement for beams. If I go to column, the column design is here, like they are providing 12 dia bars and numbers are 8, ties are there and so on. We are concerned with the wall. If you go down in the column here, you can see the design for the plates has started. Whatever the number of the plates we are having, those design for each of the plate has been done by the software. You can see there is an element 336 number, Stop reinforcement is 216 square meter per meter, and same for the bottom is there, then the transverse reinforcement is there, and so on. So here in output file the reinforcement is in mm square. Okay, it is like in mm square. So but we need like in numbers like 1 2 3, or we just need like 8 diabars of at 160 center to center, like that. So for that, what we are going to do, we are going to go into the advanced concrete design, that is RCDC. You can see here there is an option advanced concrete design. We are just going to click on it, and a new software is going to get open up. It is the RCDC, that is what we call an advanced, you can say, concrete design software. It's going to open up, and it is going to take all the result data from our stud profile, and we just have to do a couple of clicks, and it is going to give us the drawing sheets and the all the designing data. Okay, so the file has been fetched up from this particular location, and what we need to design, we want to design column and walls. Column and walls are going to design together. Okay, if you want slab, you can go with the slab or anything. So I'm just going to the column and wall. Okay, so it is going to get open up, and we are going to see. So this is going to take all the data, that is basic load cases, level data, support, section data, member properties, releases property, all the forces, geometries, grid lines, and you can say all the analysis results also. So it took around 15 seconds. In your case, it can be more fast also. Okay, so the things has been loaded up, and right now we have an design input data. Right now what we are having different level, 3 meter, 6 meter, 9 meter, 12 meter, and 15 meter. We are having different levels, and for that column and wall we can change the, you can say, the concrete grades and the, you can say, steel grades also. So I'll change the concrete grades to something else, like we want M30, so we can go for the M30. It can also fetch the directly the data from there, but this particular option provides us, you can say, options to play with. You can even change the grades and all this thing at the later stage. If you have done the analysis with some other grade, you can change the analysis, you can change the design procedure here also. Okay, so right now I'm changing all of this, you can say, the grades to 550 and all that things. Okay, so here you can easily see that we can change these grades. Okay, all the, you can say, the grades for the steel and the concrete. So I'm going to make the steel grade as FE 550, and for particular, that is concrete, we are going to go with the M30. I'm not changing the properties for beam right now, as we are concerned only about the columns and walls. Now the second thing you have to do, you go to settings, click the design setting, and check these options if you want to include any crack width analysis or like that. I'm just pressing it OK. I'm keeping it as it is. In the reinforcement setting, you can change like minimum number of bars or minimum die of bars, maximum die of bar. You can also check with the links and all that. I'm keeping all of this thing by as the default. Go into setting. The main thing is basic load cases. In this load cases, take all of these dead load and live load onto the right hand side, and then press OK. Now you can make here, you can say, the load combination by yourself, or you can add from the analysis also. So you can click add from analysis, and it will take all the loads from the analysis. I'm going to press OK here. And now into the setting, there is only one thing, that is design. Go into design and click on auto design. Okay, it will start designing columns and walls as per, you can say, the loads taken from the stud file, and depending on the properties that we have finalized here, it will design all of the columns and beam. Now this is how the design box will look like. If something is going to get failed, a pop-up box will be there suggesting that this particular member has been failed. So right now, none of the members have been failed. This C1, C2, C16, C19 all are column. This is CW1, CW1, CW1. These are what? These are our shear walls. You can click on any one of the shear wall, and you can go into the reports and click detailed drawing. Okay, so it is asking which drawings do you need for all column or for all combined column. I just for all combined walls, I just need it for the walls, and from 0 to 15 meter I need. I'll press OK. That is from top to bottom. I need the detailing. It will generate a column detail drawing, you can see here, and it will open up in front of you. So this is our main, you can say, shear walls, and this shear wall is having this kind of reinforcement. You can see the reinforcements are all situated here. This is a T8, that is 8 dia bars are there, and as I told you, there is an 4 bar column at the junction, or you can say at the corner, and this will act as, you can say, inbuilt column, and all this 8 dia bars have been used throughout, you can say, your wall. Okay, these are the link properties. These are also 8 mm at 250 centimeter links are there, and you can say this is the design. You can easily first save the project, and then you can click this disk button to save this file as an DXF file. Okay, then you can easily open it up in your AutoCAD, and you can give it to your, you can do site and all. This is here also you can say the reinforcement has been written like 48 means the 8 dia bars, and there is a total 4 count at this corner and at this corner, and in between we are having the same 18 dia bar at, you can say, groups have been made like 16 T8 bar means these are the total 16 bars at this particular junction, then there are again 18 bars, then there are 14 bars, then there are again 18. So total you can easily count out like doing the addition. Okay, so I hope this video helps you out in the understanding the basic concept of, you can say, shear walls, how the shear wall can be analyzed, model and design with the help of Staad and RCDC. If you have any other question, you can drop the comments in the section down below, and if you want me to analyze it through an E-tab and then do the RCDC version, please do let me know. We will also make a video on it. Okay.